Hello everyone, this is Shravan sir, making maths simple for you. Welcome to my YouTube channel called Maths Academy. Dear student, today in this video, we are going to prove the Centroid formula. Here we go. Dear student, in the previous videos, already we have proved the distance formula and the section formula. If you have not watched, please watch it so that it will be easy to understand the proof of the centroid formula. So dear student, here the question is prove that the centroid of a triangle with vertices A x2 y1 z1, B x2 y2 z2 and C x3 y3 z3 is given by x is equal to x1 plus x2 plus x3 divided by 3, y is equal to y1 plus y2 plus y3 divided by 3 and z is equal to z1 plus z2 plus z3 divided by 3. So dear student, here in this question we have to find out the centroid of a triangle whose three vertices are already given. So let's prove it. So dear student, at first we have to draw a triangle. So dear student, at first we have to draw a triangle ABC. The vertices of triangle ABC are given as x1, y1, z1 and B is given as x2, y2, z2 and C is given as x3, y3, z3. So dear students, if the three vertices of a triangle are given, then we can find the centroid of the triangle. So dear student, the centroid of a triangle is the intersection point of the three medians of a triangle. So dear student, let us draw AD. So dear student, we know that the intersection point of the medians of a triangle is known as the centroid. Let us say G is the centroid of the triangle ABC. So we have shown only one median AD. No need to show all the three medians of triangle because only one median is sufficient to find the centroid of the triangle. So dear student, let us suppose that the coordinates of the centroid, that means the point G is x, y, z. So dear student, according to the property of centroid, the centroid, that means the point G, divides the median in the ratio of 2:1. In the ratio of 2:1. Now, since AD is the median means a line segment joining the vertex and the midpoint of the opposite side. So dear student, D is the midpoint of BC. So the coordinates of B and C are already given. So we can find the coordinates of the point D. Let us find out the coordinates of the point D at first. So dear student, the coordinates of the point D we can find out by using the midpoint formula. x2 plus x3 divided by 2 So dear student, at first we have to find out the coordinates of the point D. The coordinates of the point D we have found by using the midpoint formula, which is x2 plus x3 divided by 2, y2 plus y3 divided by 2 and z2 plus z3 divided by 2. So dear student, now let us find out the coordinates of the centroid by using the section formula. The point G divides AD, that means median, in the ratio of 2:1. So let's write down M1 is to M2. That means 2:1. Dear student, now let's use the section formula. We know that according to the internal division, according to the section formula of internal division, x is equal to m1 times x2. That means the x coordinate of the point D. Let's represent it by x2, m1 times x2 plus m2 times x1 divided by m1 plus m2. So let's put the value of m1. m1 is 2, so we can write 2 times. And x2, x2, y1, z1, let us suppose the coordinates of the point A, which is already x, y1, z1. And the coordinates of the point D, we have suppose x2, y2, and z2. So let's represent by the capital letters the coordinates of the point D. So dear student, x2 means x2 plus x3 by 2 plus m2, the value of m2 is 1 times x1. x1 means the x coordinate of the point A divided by m1 plus m2, that means 2 plus 1. Now 2 to cancel, then we get x1 plus x2 plus x3 divided by 3. So simply we have arranged the terms x1 plus x2 plus x3 divided by 3, which is the x coordinate of the centroid of triangle. So dear student, by following the same process, we can find out the y coordinate of the centroid. Let us do it. Dear student, let's use the section formula of internal division for y. So we know that y is equal to y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Let us substitute the values. m1 means 2 and y2 means the y coordinate of D, which is y2 plus y3 divided by 2, and m2, the value of m2 is 1 times y1 means y1 divided by 2 plus 1. m1 means 2 and m1 means 1. So dear student, so 2 we can cancel. So the value of y, we have got y1 plus y2 plus y3 divided by 2, which is the y coordinate of the centroid of triangle ABC. Next, let us find out the coordinates, the z coordinate of the centroid. So dear student, again let us use the section formula of internal division. Z is equal to So dear student, already we have found the x coordinate and y coordinate of the centroid. Let us find out the z coordinate. So dear student, let us substitute the values. Let us substitute the corresponding value of m1, m2. and Z1, Z2. So we know that M1 is 2, M1 is 2, M1 is 3, M2 is 2 is to 1. So M1 means 2 and Z2. Z2 means the Z coordinate of the point D, which is Z2 plus Z3 divided by 2. M2 means 1 and Z1 means the Z coordinate of the point A. M1 plus M2 means 2 plus 1. So dear student, by simple calculation we have got the Z coordinate of the centroid of triangle ABC. So dear student, let's review once how to prove the centroid formula of a triangle. So at first we have to draw a triangle ABC. The coordinates of ABC we suppose as x1, y1, z1. B we suppose as x2, y2, z2, and the coordinates of the point C we suppose x3, y3, z3, which is already given in the question. Then we draw a median AD to meet BC at the point D, and we take the centroid G as x comma y comma z, and we know that the centroid of a triangle divides the median in the ratio of 2 is to 1. So by using the sectional formula, we can easily get the value of x, y and z. So at first we have find out the coordinates of the point D, which is the midpoint of BC. We know that the according to the midpoint formula, the x coordinate is equal to x2 plus x3 divided by 2. Similarly, y coordinate and z coordinate we have found by using the midpoint formula. Then after getting the coordinates of D, we have taken the ratio 2 is to 1, and by using the sectional formula, we have got x coordinate, y coordinate and z coordinate of the centroid of triangle. So dear student, I hope that you have understood how to prove the centroid formula. In the next video, we'll meet with the new content. Till then, bye. Have a nice day. Thank you.